Hi everyone, Alex from AutoStore here. So this is episode 5 of How to Design an AutoStore, and this week we're going to be talking about the controller and the software that actually controls the movements of the robots around the top of the grid. So the controller itself is essentially just an industrial PC, and with every install you'd get two PCs just for redundancy, and they control every movement of the robots and every bin movement. So that holds the position of every bin within the grid. So the WMS would wave on the locations that be required to fulfill any orders, and the controller would decide which bins need to be dug up to be on the top level and do all of the bin preparation with the robots. So it's the controller that's really smart and allows there to be no wait time for the picker and makes sure all of those bins are all queued up, ready to just be continuously provided to the operators. Now, there are two main softwares that run the system, Planner and Router. The way I describe the two softwares are the Planner is like TomTom, where it'll just choose the fastest route and will stick to that single route, even if there's a load of traffic on there. Router is like Google Maps, which will dynamically adjust depending on if there's any traffic incoming. Who better to explain the differences between Router and Planner than our Director of System Design, Jonas Jakobsen. So he did a short explainer at the launch of Router, or router as he calls it in the video. So I'll just hand straight over to him and he can talk you through it.
Illustrate some of the computational complexity we are dealing with at AutoStore. When deciding a route for a robot, we will usually try to take the shortest route to the goal. When we have one robot, this task is quite straightforward, although there is always a range of different options. But since there is only one robot, we can always choose the fastest route. However, when we add robots to the grid, we are generating traffic. A route that seemed optimal when isolated might now be taking you straight into rush hour, meaning we will have to stop and wait to allow other robots to pass. Finding the best routes for hundreds of robots at the same time is incredibly complex. And this is where the router comes in. The router is a completely new software architecture that allows us to do more than 100 times more evaluations for every choice we need to make. Whether that is deciding which robot to use for what job, or which route that robot should take. And as you can imagine, 100 times more evaluations has a monumental impact on system performance and allows us to utilize every robot to the fullest. The router is also extremely dynamic. We are constantly re-evaluating all the routes to ensure the best possible traffic flow, always. This means that we can easily adapt to changes like cancellations, new prioritization, or unexpected order income. When adding robots to a system, you will eventually reach a limit to what is sensible due to robot traffic. With the router, we have essentially increased the potential of every AutoStore system, allowing you to keep adding robots while making each robot more efficient.
So I thought that's a really good explainer as to what router is or router is, and why it's made such a difference to all auto stores generally. What's really good is you can actually start with Planner and then upgrade to Router further down the line. So you can start with a smaller system and then you can get 40% more efficiency out of your current system by just upgrading the software. Obviously, there's a cost associated with that, but 40% uplift is a lot cheaper than 40% more robots and ports. So that's obviously a bit of a no-brainer, I think, in my view anyway. And because of that, Root is our default of what we would use for any new projects. So that's it for this week on the controller and the software driving the AutoStore. Next week, we're going to go on to the ports where the operators will actually interact. So we'll be going over a number of weeks going through the different ports and why you'd use one over the other and trying to compare each of them. So stay tuned. Thanks very much.